We've definitely seen analytics evolving from, a few years ago where we was looking at a lot of historical data and databases, things like that, really starting to get into big data, cloud computing, and now we're looking at real-time and predictive analytics. So we're going to talk about that evolution and also the evolution of value for data and analytics. So I'm going to do some quick introductions for our panelists, and then we'll go ahead and just start diving right into questions. And we have Amir Husain, who is the founder and CEO for SparkCognition. So thanks for joining us, gentlemen. I'm going to take a seat here, and we're really just going to dive into some questions around analytics and how they connect with some of those key concerns that are facing power companies today. So in a recent, let me look at my notes here, in a recent utility dive, State of the Electric Utility in 2015, some of the top business concerns there were old infrastructure, aging workforce, and the current regulatory model. There are definitely a lot of changes that are happening in those areas. So from each of your perspectives, how can analytics really help deal with some of those challenges?
To me, information represents experience when it is abstracted as a pattern. At the end of the day, experience is a set of patterns. And now we like to think of it in terms of folksy stories because the neural network that we carry within our cranium, we have a special love and affection for. But at the end of the day, artificial intelligence technology is now delivering capabilities which are quite similar in certain narrow domains. Domains such as prognostics, such as machine condition monitoring, such as being able to predict the failure of an asset prior to it happening. These aren't theoretical questions anymore. We work with a $4.5 billion pump manufacturer, and they had their existing threshold-based infrastructure that would give them about an hour's forewarning prior to an error or a problem occurring. And by applying our algorithms, we extended this to 5 days. We're working with one of the largest aerospace companies in the world that service aircraft and need to turn them around very quickly. A lot of the maintenance crew that needs to clear those fault codes and address those issues are not fully aware of all of the nitty-gritty, all of the details, and how the replacements need to happen and what panels need to be removed and so on. So we built a cognitive system that is also powered by IBM Watson. We're an IBM Watson partner on the industrial internet side, that now delivers on an iPad the ability for every technologist, for every maintenance worker to not only know what problems have happened, to also get insight into problems that are about to happen and get the best recipe, the very precise set of steps that they need to carry out in order to resolve the problem. So across these two areas, the workforce aging, and with that, leaving organizations and departing with knowledge, we will have algorithmic systems that will retain knowledge. Every kind of knowledge tomorrow? Probably not, but a lot of knowledge. And the key there is accelerating investments and accelerating adoption of smart technology that can have infinite pattern capture scalability, because that really is the mind of the company going forward. So we believe very strongly in this, and to us, applications of AI combined with big data are really very, very important to addressing many of these challenges that Christine highlighted.
Thank you. So, there are definitely a lot of opportunities here and value within analytics. And, one question that I had is, how have analytics really evolved over the past few years? We've seen it going from, historical data, business intelligence. What is the key change that you've seen in analytics and data in the past couple of years?
That's a great question. And we learn a lot by looking at it that way, right? So my belief is that the past has been around the logistics of big data. We've been talking about implementing sensor networks and how we capture and stage the data and network conduits that are sufficient in order to deliver that data to a database, and whether it's a relational or otherwise system. And by the way, how are we going to run processes on this? That might be a Hadoop job. Those are all the plumbing, logistical considerations of, gosh, look, now I have data. And now is when the interesting elements brought to the fore, which are, what do I do with the data? And that is a cognitive science, an artificial intelligence, a pattern recognition problem. I think that the success of these analytics, the success of these big data endeavors in large companies, particularly energy companies, will only happen when AI and big data combine to yield big insights. Because at the end of the day, what has all this technology done for me as a business? And if you can come in and say, this artificial intelligence model building technology can use that data that you've been collecting over the last 5 years, you now have automated models, not just for the type of equipment, but models that can customize themselves to the specific needs, the specific maintenance histories, and the specific operating conditions of each and every single asset without human intervention. That's a quantum of monitoring that the traditional means of machine condition monitoring simply cannot provide.
Yeah, I mean, so it sounds like, I mean, obviously there are huge opportunities with data and analytics. And the question I had was, I mean, how do you keep analytics from really being a separate effort within an organization? You know, how do you really get that integrated? I feel like sometimes I talk with companies and, oh, you know, they have their data scientist, their data expert, or it's the IT piece or the business piece. So how do you really start to bring those groups together and really integrate data and analytics into an organization?
I suppose my feeling is that in order to make anything important to a business, it has to be aligned with the objectives of that business, and it has to be perceived as a major tool or an avenue that will help achieve the objectives of that business. In the energy business, for example, reliability, safety, optimality, reduced footprint, there might be a number of such metrics. And the data now is available that can be combined with the right algorithms, the right insights to be able to create, for example, automated maintenance schedules that would be far more effective, cognitive maintenance schedules that would be far more effective than what a human workforce would build. You also have many other opportunities. You know, again, one of our customers is a rail operator, and they encounter these issues where they're going down a track cross country and the wheels go out of round. The track operators have sensors embedded at different places on the track, and as the pressure rating exceeds a certain number, there is a penalty. The train gets pulled to a side, and there is a punitive replacement, a very high dollar charge that gets placed on them, and there is an increased danger of an environmental impact while that activity is happening. So by creating a system that uses their existing data to solve their biggest problem, which is, give me something that I can design my train that I'm sending from Dallas to wherever else in the country, give me a very accurate model that tells me which one of these cars will fail, which ones will get there, and then give me options. Tell me, can I reduce the speed? Can I reduce the load? Could I take a different route? Because perhaps some of the routes go through very cold climate, and we know that cold climates increase the chances of a failure. That's the solution to a business problem. Now, where we've taken that app is that this customer is working to incorporate economic data and environmental data. And the next version of what we're delivering will actually have a dollar number on the screen. You can go now, and you might have one failure in environmental impact area. This is what it's going to cost you most likely. You choose not to go or to go slow and you miss an SLA, and that's what it's going to cost you. So the point is that when you embed powerful data analytics, AI, cognitive technology that is making decisions that individual human beings cannot make, and are aligning the workflow so that the users within the company don't have to bother about the complexity of the technology. They don't need to know that this is running on Apache Spark and Apache Hadoop and how large the database is and whether it's a graph database or something else. They're simply looking at a user interface, building a train, clicking a button, you figure it out. Does it get there? No, it does not. Click a button, replace the bogies automatically, and you're done. Train built. Your impact reduced. When we do things like that, we see that we drive sea change. We started working with a partner that covers 200,000 of the 500,000 oil tanker rail cars in the US. We recently attended a conference. They got 20 large railroad operators there. And this is something that's becoming somewhat of a movement. The reason it's becoming somewhat of a movement is because we've aligned the capabilities of cognitive and big data with the biggest business problem in that category. We need to do more of that. When we do that, these sorts of capabilities will subsume into organizations and they'll become par for the course. You've got to make a difference.
Yeah, I mean, it sounds like really aligning it with those business objectives and, all the different aspects that come along with running an organization. Now, I heard people mentioned a lot, and I think there are concerns around, machine learning, all of these things, replacing people, that sort of balance. I mean, how do you achieve that balance between people and, machines?
I have this in my hand, so maybe I'll start and pass this along. I have a lot of empathy for machines. I think they're fascinating, and I think they are the source of ideas and thought that we are incapable of. And I think that working in concert with them is probably the best path forward for us, because they present intelligent machines, give us the opportunity to augment human potential. That's what it's all about. On a more, shed the philosophical for a moment, on a more practical matter, this country simply isn't producing the number of data scientists that we need. If you look at the rate at which data is growing, it's very much an exponential trajectory. And the rate at which data scientists are growing is very much a linear trajectory. That gap is continuing to increase. So are we going to seed the insights and the value that is found in the data that we can't get to as human beings, and yet hold on to the way things were done and shall always be done? Or will we be a little brave about it and look to change our ways and look to acknowledge that perhaps there are semi-intelligent tools now that we can leverage? And you know what? I don't know whether Ray Kurzweil is right or wrong. I don't know whether the singularity is going to happen. But even if it does, it's decades away. I don't think the fears that we project with regards to things like that really should influence fundamental, real engineering work that's happening in these areas. These areas are delivering benefits. So to me, that's the way I look at it. I look at it as a way to augment human potential. That to me is the most noble thing I can be a part of, right? It's not us versus them. It's how do we make ourselves better.
Do we have time for a couple of questions? Are you?
Sure.
Okay. All right. So are there any questions out there in the audience? And I'll come up to you with the microphone.
Is all this big data, is that publicly available?
Two quick things, just on a practical level. Some of the data that we think is really hard to get is not that hard to get. There are efforts underway in the academic community, for example, where inexpensive devices that you can connect to your home electric sockets let you gather synchrophaser data that you would otherwise have to go and get from a utility. So that's one example. There are open government initiatives where you don't get all the data, but you get quite a lot of the data. Working with customers that are subject to a lot of constraints around who they can share that data with, I think it'll be quite a bit of time before we can get them comfortable, alter legislation, create some sort of a system to do PI extraction and some sort of a, removal of key elements. The other thing you also have to remember is that there's a very significant cyber threat landscape which impacts all of these systems now. Large energy producers, distributors, and their data are a national security asset from a military and defense standpoint. And it can very easily be identified for problems and issues that can be then exploited. The DOE recently set up that Project Aurora, where hackers were able to log in and purely using software, they were able to create vibration signals that blew up a generator. There's been numerous other cases from Stuxnet to the Siberian oil pipeline. So large industrial systems have so much kinetic energy and they're completely computer controlled. They're essentially bombs of various different types. And that data can provide a lot of insight as to how they operate. So there's that whole layer of concern around the cyber-physical threat that needs to be looked at also.
All right. Please join me in thanking our panelists for the great insight.